This is week one of systems analysis and design. I want to first make clear that these recordings are not intended to replace your readings. It's important that you first read the material in the text and then move to these recorded slide presentations for each week, as they will actually clarify and enhance what you've read in the text. In this week, we'll cover chapters 1 and 2, which is the introductions to systems analysis and design, and in chapter 2, analyzing the business case. Companies use information systems as weapons in the battle to increase productivity, deliver quality products, maintain customer loyalty, and make good decisions. Information technology can mean the difference between success and failure. It also can mean the difference between gaining a competitive edge, achieving operational excellence, and in some cases, even survival. When we talk about information technology, we're talking about that combination of hardware and software, products and services that companies use to manage, access, communicate, and share information, not just internally, but also externally through systems such as supply chain management systems, internally through intranets. We'll talk about all these later in the course. For the future, there are three issues that will shape the future of the IT world. One is changes in the world. You're seeing that right now with significant economic problems worldwide. All world economies at this moment are somewhat depressed, if you will. There are also changes in technologies. These will have the biggest impact on systems analysis and design, and that's because technology changes in our world so rapidly. Technologies that were new and cutting edge just a year ago are in some cases becoming nearing obsolescence. And also there are changes in client demand for a variety of reasons, not the least of which is, as we indicated, the economy right now. As this slide indicates, business information systems are developed by people who are technically qualified, business oriented, and highly motivated. Systems analysts, it sounds like a very technical profession, but in fact it's not as technical as most people think. One of the key elements is good communications with strong analytical and critical skills. The reason for this is that while the IT people, systems analysts and design people, programmers, we physically build the systems. However, we have to be able to communicate with the end users to understand their needs. Also, a key element, which we'll talk about in just a little bit, is the business profile, our business systems, our business processes. Without an understanding of how these work, you can't really design good systems. So we will take a look at all of these things. Systems analysis and design is a step-by-step process for developing high-quality information systems. And we'll talk a little more later just about exactly what high quality means. But basically an information system, as we talked about, combines information technology, people, data to support business requirements, etc. One of the key people in this process normally resides in the IT department is the systems analyst. That's the person that's going to plan, develop, and maintain information systems. They're going to do that in cooperation with both management and the end users. So who develops these information systems? Well, there are a number of sources for them. First would be in-house applications. An in-house application is usually developed using your internal resources, although you might hire consultants or additional assistants to do this. But the purpose of it, normally, it's driven by unique business requirements that can't be met by software packages or outside sources. And that brings up a second source, which is software packages. Many times information systems, business systems especially, you can buy a software package that will basically meet all your needs. When those packages don't, then of course we fall back to the in-house applications. You can also get what are called internet-based application services. A very popular evolution in this has been the development of ASPs, or application software providers. They're internet-based companies that allow you basically to use their services. That can be just the software, or there are services that also provide all the hardware and everything behind it. An example would be Salesforce.com. They allow you to go in, modify the software to meet your needs, and then keep everything in the cloud where it's easily and readily available to uh, your Salesforce, for example. Those people are out on the road quite often, maybe accessing through mobile devices, so it's a key element. Another information system source can be actual outsourcing, where you have somebody come in, for example, a Deloitte and Touche or a PeopleSoft, somebody like this who has teams that will come in and actually build your application for you. And that can be based on a software package that they sell, or they will build custom solutions for you. There are also a number of enterprise-wide software strategies, which we'll later talk about. And when we talk about enterprise-wide, what we really mean is integration between all aspects of the company. And we're going to talk a little bit about how versus what. What that is will become apparent to you in just a few minutes. Let's talk for a minute about information system components. This slide draws your attention to exactly what those are. What I want to key in on here is that information systems have 5 key components. These are hardware, software, data, processes, and people. Hardware you're familiar with. That would be the physical layer of the information system. Servers, computers, network infrastructure, mobile devices, all of those things. The software is a software system. You have both application software and enterprise applications that we're going to be concerned with during much of this course. You also have what are called horizontal systems, vertical systems, and legacy systems. Legacy systems meaning your old systems which are in place. And one consideration of a new system will always be, can it communicate with the old system, and does it need to? What about the systems that this system doesn't replace but that you still use? To be effective, it has to communicate with those legacy systems also. We're also going to think about data, how it's stored in tables, how the tables are linked together, and how it becomes information. And how it becomes information is basically through processes. Processes describe all the tasks, business functions that the users, the managers, the IT staff members would perform to achieve results. And then finally, and probably one of the key elements in any information system, is the people, which consists, as you're aware, of the users or end users, but also of the stakeholders. And we'll talk more about stakeholders later. Business process modeling is a technique that systems analysts use to represent a company's operations and information needs. The business processing modeling requires you to have a business profile and a series of models that actually document the different business processes. Now, a business profile is nothing more than an overview of the company's missions, functions, organizations, products and services, customers, suppliers, competitors, constraints, future directions. It seems like a lot of information, but it's all critical in the design of an information system. Now, business process re-engineering is a method that is used to take a look at your business processes and attempt to reduce redundancies, gain efficiencies, and basically provide a better business model than the one you're currently using. Oftentimes that's based on best practices. Understanding the business isn't all that difficult, and most of you would be familiar with this anyway. You understand production-oriented businesses, service-oriented, internet dependent, such as Amazon.com, and then your .coms in general. The one part I will explain a little bit about is brick and mortar. But basically that is like the old record stores, or like the J.C. Penney's, or even the Walmarts. Brick and mortar refers to the type of business whose primary business model includes a physical location and inventory and customers coming in and that kind of thing. And that's what we mean when we're talking about brick and mortar. Now we need to take a minute and look at the impact that the internet has had on businesses. In general, when goods are bought and sold over the internet, we call that e-commerce or I-commerce, internet commerce. Basically, there are three forms of it, two of which we're going to be concerned with right now, right here. The first is business to consumer. That would be like when I go on Amazon.com site and I want to buy some books, or Amazon sells about everything now, or something else. And I do a transaction and it processes, and that's business to consumer. However, far and away, the biggest use of e-commerce is business to business. It dwarfs business to commerce by comparison. A couple of components that make up business to business e-commerce. One is EDI, which is electronic data interchange. This is a data sharing interchange between businesses, not just transactions. Invoices can be submitted this way, bills of lading, contracts can be exchanged. It was designed specifically for business to business sales. Another thing we're going to look at is extensible markup language. That was, again, specifically designed for business to business commerce. And what it does is enables company to company traffic to migrate to the internet, which what it did was XML offered a standard set of protocols, universal availability, and very low communication costs. It's a flexible data description language that allows web-based communications between different hardware and software environments. Two other concepts that are important are SCM, which is supply chain management, which we'll deal with quite a bit later, and also SRM, which is supplier relationship management. These are two types of information systems which we will see again in the near future here. In the past, IT managers divided systems into categories based on the user group the system was designed to serve. Things like office systems were used primarily by administrative staff, and that would be the HR system, accounts payable, accounts receivable. And then there were operational systems used primarily by operational personnel. Next would be decision support systems. These are DSS systems are used primarily by middle managers and knowledge workers, and they're designed to assist them in better decision making. And finally, you have what are called Executive Information Systems, or ESS, Executive Support Systems. These are designed for top managers, and what's unique about these systems is that they draw from not only internal sources and systems, but also external sources, often bringing in census data, market data, news feeds, all kinds of things that top managers, top level managers need for strategic decision making. Today, managers identify a system by its functions and features rather than by who uses it. Part of this is an outgrowth of what we call ERP systems, or enterprise resource planning type systems. Some examples would be CRM, customer relationship management, SCM, which is supply chain management systems, and actual ERP packages, which are enterprise resource planning type packages. Another category would be transaction processing systems, which we've already described, business support systems, knowledge management systems, which we'll go into in some depth in a few minutes, and also user productivity systems. We've already mentioned some of the types of enterprise computing systems. Here we'll clarify just a little more and say that what makes these especially valuable is their integration between all other types of systems. Managers, especially the higher you go, the more information they need at a summary level to help them make decisions. I will tell you that many software vendors target the enterprise computing market, in part because these are massive systems, they're very expensive, hence very profitable, but they are also tremendously effective. Let's look now at a typical transaction processing system, or TPS system. They all involve large amounts of data, and they're almost always mission critical. They're efficient because they process a set of transaction-related commands as a group rather than individually. So, for example, if I go online, again, let's use Amazon.com, and I'm buying my book, what actually happens? Well, the first thing is, with Amazon, they're going to check my credit card status. Well, before that, they're going to verify, do I have an account with Amazon? If I do, then I'll go ahead and do my order, and it'll check my credit card status. If I'm approved and my credit is available on my credit card, then they will go ahead and post it to accounts receivable while simultaneously checking to see that if it's in stock. If it is, It'll set my book aside and adjust the inventory levels appropriately, and then it'll update the sales activity file. It will also send a notice to the shipping department to package and ship my book out to me. Business support systems provide job-related information to users at all levels of the company. Example would be a management information system. This type of a system is used primarily by middle management and consists mostly of pre-formatted recurring reports as opposed to anything that would be like an ad hoc report. Another type of useful business information system would be an RFID system. You've seen these. They are used for inventory control and management and a host of other applications. This slide does a very good job explaining what knowledge management systems are. The one area that you may not be familiar with is fuzzy logic. In essence, fuzzy logic allows inferences to be drawn from, let's call them imprecise relationships. In a minute I'll give you an example. But by using fuzzy logic, values don't need to be black or white and specifically spelled out. They can be shades of gray. Now, an example of this would be if I've got three 8-year-old girls and one of them is 6 inches taller than the other two. And I say, that's a tall girl. Well, you and I, based on my voice, my inference, and by our visual cues, you know exactly what I mean when I say she's a tall girl. But a computer can't grasp, can't process that concept. And so we need what are called inference rules using fuzzy logic. And that's done by putting things in a context, the inference rule, and then applying ranges to those contexts. So within the set of all 8-year-old girls, the one 6 inches taller is indeed tall, but be compared to an adult, she's not. You and I, again, can make that distinction, but computers generally cannot. So fuzzy logic is an attempt to be able to allow computers to process imprecise references that humans can do out of hand. User productivity systems include things like email, voicemail, fax, video, web conferencing, word processing, automated calendars, database management, spreadsheets, desktop publishing, presentation graphics, company intranets, and also high-speed internet access. Another form of user productivity is called groupware, and these are programs that run on a company internet and enable the users to share data, collaborate on projects, and work in teams. GroupWise by Novell is an example of groupware. In addition to understanding business operations, a systems analyst must know how to use a variety of techniques such as modeling, prototyping, computer-aided systems engineering tools to plan, design, and implement information systems. Modeling produces a graphical representation of a concept or a process that systems developers can analyze, test, and modify. A business model or requirements model describes the information that a system has to provide. The data model describes the data structures and the design. An object model describes objects which combine data and processes. Network model, that describes the design and protocols of the telecommunications links. And finally, a process model describes the logic that programmers will have to use to write the different modules. A prototype is an early working version of an information system. A prototype can serve as the initial model that's used as a benchmark to evaluate the finished system, or it can actually develop into the final version of the system itself. Either way, prototyping greatly speeds up the entire development process. Case tools, as described in this slide, tremendously speed up the implementation process. They generally contain what's called a code generator, where you tell the tool what it is you're trying to achieve, and the tool itself will actually write the code for you. Case tools are covered in depth in Part B of the Systems Analyst Toolkit, which will be part of next week's assignment. Structured analysis is just one of many options that exist for developing software systems. It is a very traditional approach that encompasses what's called the Software Development Life Cycle, or SDLC. As indicated here, it's a predictive approach that uses a set of process models to describe a system graphically. If you look at the illustration on the right, that's an example. It is a process-centered technique, and it uses what's called the waterfall model. And if you look on your textbook on page 23, figure 127, there's a complete explanation of what the waterfall modeling means. Structured analysis is probably the most traditional of the systems development techniques. It's time-tested, it's easy to understand. It uses a series of phases called the software development life cycle to plan, analyze, design, implement, and support an information system. In the course of the next series of slides, we're going to take a look at each individual phase of the SDLC model, including planning, analysis, design, implementation, support, and security. The systems planning phase usually begins with some kind of a formal request to the IT department called a systems request, which describes the problems or the desired changes in an information system or a business process. The purpose of this phase is really to perform the preliminary investigation to evaluate the IT-related business opportunity or problem. It's actually the most critical step because all the other steps rely on this one. And a key part of this preliminary investigation is what's called a feasibility study that reviews the anticipated costs and benefits, recommends a course of actions based on operational, technical, economic, and time factors. The purpose of the systems analysis phase is to build a logical model of your new system. The first step is what's called requirements modeling. This is where you investigate the business processes, document what the new system must do to satisfy the users. And when we say users, we're talking about both system operational type users, but also management users. The deliverable for this systems analysis phase is called the Systems Requirement Document. It describes the management and the user requirements, lists out the costs and benefits, and it also outlines alternative development strategies. That moves us then into what's called the systems design phase. And the purpose of systems design phase is to take the information we got in that system requirements documents and create a physical model that will satisfy all those documented requirements for the system. The deliverable for this phase is the system design specification, which is presented to management and their users for a review and approval. Management and user involvement is critical to avoid any kind of misunderstanding about what the new system will do, how it will do it, and very importantly, how much it will cost. During the systems implementation phase, we'll actually build the new system. The objective of the systems implementation phase is to deliver a completely functioning, well-documented information system. At the conclusion of the implementation phase, the system is actually ready for use. Final preparations, which we'll talk more about later, include converting data into the new system's files, training the users, and performing the actual transition or cutover from the old to the new system. And that leads us into the system support and security phase, where the IT staff maintains, enhances, and protects the system. The objective during this phase is to maximize our return on investment. Security controls will safeguard the system from both external and internal threats. A well-designed system has to be secure, reliable, maintainable, and scalable. A scalable design means that it can expand to meet new business requirements and volumes. Unlike structured analysis, which builds an overall plan for the entire information system, Agile methods attempt to develop a system incrementally by building a series of prototypes and then constantly adjusting them to the user's requirements. As the Agile process continues, developers revise, extend, and merge earlier versions into a final product. An Agile approach emphasizes continuous feedback, and each incremental step is affected by what was learned in the prior steps. Several other software development methodologies have been devised and have become very popular. Two of these that I'm going to talk about here are Joint Application Development, or JAD, and rapid application development, which is RAD. Both of them use teams that are composed of users, IT managers, and IT staff. The difference is that JAD focuses on team-based fact-finding, which is only one phase of the development process, whereas RAD is more like a compressed version of the entire process. JAD and RAD are what are called agile development methods. We're going to talk quite a bit more about these in Chapter 4 coming up. This slide provides you with some systems development guidelines. Number one, you're going to develop a project plan, and we'll talk later about how that's done and what goes into it. You have to do that by involving the users, and that includes management, of course, and you have to listen carefully and document everything. Oftentimes users know what they want but have a hard time telling you. You'll also use project management tools to identify tasks and milestones. These tools will be described in depth in Chapter 3. And it's important to develop accurate cost and benefit information. There's an old saying that you can do anything if you got enough time and money. One key element that you have to get across is what something is going to cost. Yes, it can be done. You'll learn not to say, no, that can't be done. But you have to make people understand how much it will cost to do what they want to do. Slides 30 and 31 provide kind of an overview, a summary of the chapter. Read through this slide and the next one, and make sure that you understand the bullet points there. If you don't, go back to the text, read through that material again, because these are the things that we will build on in the next chapter. Many businesses move forward on the basis of a series of projects. You need a strong business case for your project to make sure that it's chosen above the alternates. A company always has more projects than it has money to complete these. So the stronger your business case, the better the chances that your project will rise to the top when it comes time to prioritize. And we'll talk about prioritization a little bit later. Successful IT managers engage in long-range planning. Even while they have to handle day-to-day maintenance and support, which takes up the bulk of their time, they have to be involved in the strategic planning process. By definition, strategic means looking beyond day-to-day activities and focusing on the horizon, 3, 4, 5 years down the road. Strategic planning normally starts with a management review, which is called a SWOT analysis. Most of you will be familiar with the SWOT analysis. It stands for strengths, weaknesses, opportunities, and threats. Oftentimes it can become an academic exercise, but it shouldn't be. It's a key element and a critical starting point when you're doing strategic planning. Every company does strategic planning somewhat differently. There's no standard approach to strategic planning. Some managers believe that a firm's mission statement should contain an inspirational message to its stakeholders. Others feel that unless a firm starts with a realistic SWOT assessment, it might develop a mission statement that's unachievable. The majority of companies view the strategic planning process as a dynamic interaction, similar to the diagram shown at the left. What should the role of the IT department be in project evaluation? 10 years ago, a typical IT department handled all aspects of systems development and consulted users only when or if the department wanted user input. Today, systems development is much more team-oriented. New approaches to systems development, such as joint application development and rapid application development, typically involve groups of users, managers, and IT staff working together right from the beginning. Although the team-oriented development is the norm, some companies see the role of the IT department as a kind of gatekeeper, responsible for screening and evaluating systems requests. Should the IT department perform the initial evaluation, or should a cross-functional team do it? The answer really depends on the company's size and organization and whether IT is tightly integrated into the business operations. If they're not tightly integrated, then the answer is no. We talked previously about the fact that projects compete with one another for scarce resources, money, time, and people. So how then do we differentiate between projects? One way that this is done is through the strength of the business case. So what exactly is a business case? A business case is the case you make that says, why are we doing this project? What's important about it? How does the solution address key business issues? How much will it cost? How long will it take? Will we suffer productivity loss during the transition? What's the return on investment and the payback period? What are the risks of doing the projects and what are the risks of not doing the project? How will we measure success and what alternatives exist? Earlier, we alluded to the fact that businesses are in competition with other businesses and in the business world and environment. They strive to achieve competitive advantage, operational excellence, create new products and services and business models to raise revenue and profits, and also to improve decision making for managers and employees. So what are some of the main reasons that systems projects get approved? Well, take a look at the slide here. Improved service would be one of the first. Better performance. Why better performance? Because the more efficient you are, the more money it saves you. And if you can cut costs, you will improve profitability. Support for new products and services? Perhaps we just need more information to compete. Maybe we need stronger controls. But the bottom line is we're almost always looking to reduce our cost and improve our operational performance. Internal and external factors affect every business decision that a company makes, and IT systems projects are no exception. The figure shown here shows many of the main internal and external factors. For example, let's start with the external factors. Technology. What is the state of technology? What systems are available? How old is our technology? Suppliers. How well do we communicate with them and what effect is that having on our business? Customers, goes without saying. We have to communicate effectively, and the better we know our customers, the more effective we can be. Competitors. What is our competition doing? Take, for example, the first ATM machine that came out. How long do you think it took the other banks to come out with ATM machines? Why? Because the first one had a competitive edge. Also, the economy is an external factor. We've talked about that in previous slides. And never underestimate the fact that government regulation is a very large cost of doing business. So those are the external factors. What about internal factors? Let's start at the beginning, and that would be with the strategic plan. Does what we're doing support our strategic plan? Also, are the top managers involved? What about the users? Is this request going to meet user needs? Information technology department. Do you have the resources you need, or are you going to have to outsource this? And finally, you must consider your existing systems and data. Will your new system work effectively with your existing systems? As mentioned earlier, business case analysis involves consideration of project's reasons, costs, benefits, and risks. At the end of the preliminary investigation, if your project is approved, then it can be planned, scheduled, monitored, controlled, and reported on. We're going to talk a lot in Chapter 3 about project management concepts, the skills, the tools, and the techniques that are necessary to be successful. At this point, let me just say that the things that make a person a good business manager are not necessarily the same tools that make a person a good project manager. They are significantly different, and we'll go into that in some detail in the next chapter. In most organizations, the IT department receives more system requests than it can handle. Many organizations assign responsibility for evaluating systems requests to a group of key managers and users. Many companies call the group a systems review committee or maybe a computer resources committee, but regardless of the name, the objective is to use the combined judgment and experience of several managers to evaluate systems projects. Now, most organizations will use a special form or a systems request, similar to the online form shown in Figure 2-14 on page 65 in your textbook. The form has to be easy to understand and include clear instructions. It should also include enough space for all the required information, and it should indicate what supporting documents are needed. As this slide indicates, a system request has to pass several tests called a feasibility study to see whether it's worthwhile to proceed or not. Sometimes this feasibility study is quite simple and can be done in a few hours. But if the request involves a new system or a major change, extensive fact-finding investigation is going to be absolutely required. How much effort needs to be expended depends on the request itself. First, we'll look at the operational feasibility aspect. Operational feasibility means that a proposed system will be used effectively after it's been developed. If the users have difficulty with the new system and can't use it, then it was the wrong system. Operational feasibility depends on several vital issues. For example, does management support the project? Do the users support the project? Is the current system well liked and effectively used? Do the users need the change? Will the new system result in a workforce reduction? And if so, what will happen to the affected employees? Will the new system require training for users? Almost always. Will users be involved in planning the new system right from the start? Will the new system place any new demands on users or require operating changes? Will customers experience adverse effects in any way, either temporarily or permanently? Will any risk to the company's image or goodwill result? And does the development schedule conflict with other company priorities? Also, what are the legal and ethical issues involved? Our feasibility study also has to cover technical feasibility, which refers to the technical resources needed to develop, purchase, install, and even more importantly, operate the system. What does that mean? Do we have the necessary hardware, software, network resources, and if not, can we get them? Will a combination of hardware and software supply adequate performance? Do clear expectations of performance specifications exist? Will the system be able to handle future transaction volume and company growth? These are just a few of the questions that we'll have to ask when we're assessing technical feasibility. Economic feasibility means that the projected benefits of the proposed systems outweigh the estimated costs, which are called the total cost of ownership. Total cost of ownership includes ongoing support and maintenance costs and acquisition costs. To determine TCO, the analyst has to estimate costs in each of the following areas: people, hardware and equipment, software, formal and informal training, licenses and fees, consulting expenses, facility cost, and the estimated cost of not developing the system or postponing the project. In considering total cost of ownership, we have to look at both tangible benefits, which are easily quantified and measured, but also intangible benefits, which are much more difficult to quantify and measure. For example, how do you put a value on improved customer service or improved employee morale? These things are real, but how do you measure and quantify them? And finally, we'll look at schedule feasibility, which means that a project can be implemented within an acceptable time frame. When you're looking at this, you have to consider, can the company or IT team control the factors that affect schedule feasibility? Has management established a firm timetable for the project? Will project management techniques be available to coordinate and control the project? And will a project manager be appointed? We'll discuss all of these more in Chapter 3. After rejecting systems requests that aren't feasible, the Systems Review Committee has to establish priorities for the remaining items. The highest priority goes to the projects that provide the greatest benefit at the lowest cost and in the shortest period of time. Many factors, several of which are shown on this slide, will influence that project evaluation. Whenever possible, the analyst should evaluate a proposed project based on tangible costs and benefits that represent the actual or approximate dollar values. Intangible costs and benefits often influence systems decision priorities and must also be considered carefully, but the primary deciding factors should be based on tangible costs. While a project might be very desirable, we have to ask ourselves the question, is it absolutely necessary? Projects where management has a choice in implementing them are called discretionary projects. Projects where no choice exists are called non-discretionary projects. Creating a new report for a user is an example of a discretionary project. Adding a report required by federal law is an example of a non-discretionary project. A systems analyst conducts a preliminary investigation to study the system's request and recommend some specific action. After obtaining an authorization to proceed, the analyst interacts with the managers and users. The analyst gathers facts about the problem or opportunity, project scope and constraints, project benefits, and the estimated development time and costs. The end product of the preliminary investigation is a report to management. During the preliminary investigation, the systems analyst typically follows a series of steps. The exact procedure depends on the nature of the request, the size of the project, and the degree of urgency. Step 1 is understanding the problem or opportunity. 2, defining the scope and the constraints. 3 is to perform fact-finding. Step 4 is to analyze project usability, cost, benefit, and schedule data. Step 5 is to evaluate the 4 parts of feasibility that we've talked about: operational, technical, economic, and schedule. And step 6 is to present the results and the recommendations to management. For step 1, understanding the problem or opportunity, a popular technique for investigating causes and effects is called a fishbone or Ishikawa diagram. A fishbone diagram, it's an analysis tool that represents the possible causes of a problem as a graphical outline. When using a fishbone diagram, an analyst first states the problem, then draws the main bone with sub-bones that represent the possible causes or problems. For example, if the problem is unhappy workers, and the analyst has identified 4 areas to investigate: environment, workers, management, and machines. In each area, the analyst identifies possible causes and draws them as horizontal subzones. For example, too hot is a possible cause in the environment bone. For each cause, the analyst has to dig deeper and ask the question, what could be causing this symptom to occur? For example, why is it too hot? If the answer is insufficient air conditioning capacity, the analyst indicates this as a subbone to the too hot cause. In this manner, the analyst adds additional subbones to the diagram until he or she uncovers the root causes of a problem rather than just the symptoms. In step 2, defining the project scope and constraints, we're going to consider 3 important aspects. First is project scope, then project creep, and then constraints. Determining project scope means defining the specific boundaries or the extent of the project. Sometimes, believe it or not, that can actually include specifying similar or parallel systems that are not within the scope of the project. Projects with a very general scope, very general definitions, are at risk of expanding gradually without specific authorization in a process called project creep. This occurs because as the specifications become more and more clear, the size of the project actually grows. The difference between project creep and scope creep is important here. We'll talk about scope creep in chapter 3. But scope creep is where tasks and pieces get added onto the project in addition to the original specifications. And finally, along with defining the scope of the project, you have to identify any constraints that are on the system. And a constraint is a requirement or a condition that the system has to satisfy or an outcome that the system has to achieve. A constraint might involve hardware, software, time, policy, law, cost. System constraints also help define project scope. When you're examining constraints, you're also going to have to identify their characteristics. For example, present value versus future. Is the constraint something that has to be met as soon as the system is developed or modified, or is the constraint something that would be necessary at some future time? Internal versus external. Is the constraint due to a requirement within the organization or does some external force, such as government regulation, impose it on us? And what about mandatory versus desirable? Is the constraint mandatory? Is it absolutely essential to meet this constraint, or is it just desirable? Regardless of the type, all constraints should be identified as early as possible to avoid future problems and surprises. A clear definition of the proper scope and constraints avoids misunderstandings that arise when managers assume that a system will have a certain feature or support for a project, but later they find out that this feature is actually not included. Step 3 in this process is to perform fact-finding. The objective of fact-finding is to gather data about project usability, costs, benefits, and schedules. Fact-finding involves various techniques which are described on the next slide. Depending on what information you need to investigate the system's request, fact-finding might consume several hours, maybe days, potentially weeks. For example, a change in a report format or a data entry screen might require a single telephone call or email message to a user, whereas a new inventory system would require a series of interviews. During fact-finding, you might analyze organizational charts, conduct interviews, review current documentation, observe operations, or carry out a user survey. The primary method of obtaining information during the preliminary investigation is the interview. The interviewing process involves a series of steps. 1. Determine the people you're going to interview. 2. Establish objectives for the interview. 3. Develop interview questions. 4. Prepare for the interview. 5. Conduct the interview. 6. And very importantly, document the interview. And number 7. Evaluate the interview. In addition, you'll undoubtedly have to review the current documentation. Although interviews are an extremely important method of obtaining information, you're also going to want to investigate the current system. The documentation may not be up to date, so you'll have to check with the users to confirm that you're receiving accurate and complete information. Another valuable tool is to observe operations of the current system. You might see how workers carry out typical tasks, or you might choose to trace or follow the actual paths taken by input source documents or output reports. In addition to observing operations, you might also want to sample the inputs and outputs of the system. Finally, you might also want to conduct a user survey. Interviews can be very, very time consuming, so sometimes you can obtain information from a very large group by conducting a user survey. In this case, you can design a form that users complete and return to you for tabulation. A survey is not as flexible as a series of interviews, but it's far less expensive and generally takes less time, and it can involve a very broad cross-section of people. In step 4, you'll analyze project usability, cost, benefit, and schedule data. During the fact-finding, you gather data about the project's predicted costs, anticipated benefits, and the schedule issues that could affect implementation. But before you can evaluate feasibility, you have to analyze this data very carefully. If you conducted interviews or used surveys, you should tabulate the data to make it easier to understand. If you observed current operations, you should review the results and highlight the key facts that will be useful in the feasibility analysis. And if you gathered cost and benefit data, you should be able to prepare financial analysis and impact statements using spreadsheets and other decision support tools. Also, as a part of step 4, you should develop time and cost estimates for the requirements modeling tasks that are in the next phase of the software development lifecycle, which is systems analysis. Specifically, you should consider the following. What information must you obtain, and how will you gather and analyze that information? Will you conduct surveys? How many people will you interview? And how much time will you need to meet with the people and summarize their responses? Will you conduct a survey? If so, who will be involved? How much time will it take people to complete it? And how much time will it take to tabulate the results? And as the final part of step 4, you need to ask the question, how much will it cost to analyze the information and prepare a report with your findings and recommendations for management? Now in step 5, we're actually ready to evaluate feasibility. We've already analyzed the problem or opportunity, defined the scope and the constraints, and we've performed fact-finding to evaluate project usability, cost, benefits, and time constraints. Now you're ready to evaluate the project's actual feasibility. For operational feasibility, your fact-finding should have included a review of user needs, requirements, and expectations. When you analyze this, you should look for areas that might present problems for systems users and how they might be resolved. Technical feasibility, the fact-finding data should identify the hardware, software, and network resources you will need to develop, install, and operate the system. With the economic feasibility, using the fact-finding data, you can apply the financial analysis tools, which will be described in Part C of the Systems Analyst Toolkit. to assess feasibility. And then finally, the scheduling feasibility. The fact-finding data should include stakeholder expectations regarding acceptable timing and completion dates. As mentioned previously, often there is a trade-off that exists between a project's schedule and its costs. Now we're ready for step 6, present the results and the recommendations to management. But before we do that, at this stage, we have several other alternatives. You might find that no action is necessary or that some other strategy, such as additional training, is what's really needed. To solve a minor problem, you might implement a simple solution without performing any further analysis. In other situations, you will recommend that the project proceed to the next development phase, which is systems analysis. If in fact you are going to do a preliminary investigation report to management, it typically will have the following sections. Finally, step 6 is to present the results and the recommendations to management. But at this stage, you have several alternatives. You might find that no action is necessary or that some other strategy, such as additional training, is all that's needed. To solve a minor problem, you might implement a simple solution without performing any further analysis. However, in other situations, you will recommend that the project proceed to the next development phase, which is systems analysis. The format of the preliminary investigation report varies from company to company, but a typical report might have the following sections. Introduction. The first section is an overview of the entire report. It contains a brief description of the system, the name of the person or group who performed the investigation, and the name of the person or group who initiated the investigation. Second section would be systems request summary, and obviously it summarizes and describes the basis for the system's request. The third section would be called your findings. The findings section contains the results of your preliminary investigation, including a description of the project's scope, constraints, and feasibility. And the fourth section is a case for action. It's a summary of the project request and the specific recommendation. Management will make the final decision, but the IT department's input will be an important factor here. The next section of the report identifies project roles. This lists the people who will participate in the project and it describes each person's role. Next section will be time and cost estimates. This describes the cost of acquiring and installing the system and the total cost of ownership during the system's useful life. Next will be expected benefits. In this section, we will include the anticipated tangible and intangible benefits and a timetable that shows when we anticipate that they will occur. And finally, you may have an appendix. This will be included in the report if you need to attach any supporting documentation. The next 3 slides attempt to cover all the main points that we covered in the chapter. Please read through these. If there's any point of which you're still unclear, I would go back and listen to the slide that covers it, or go back to the text and review the information there. This concludes the Week 1 materials.